we talked about the deviation of a prism, where we compare the incident ray of light to the emergent ray of light. And you can measure the angle between them and calculate how much did this prism change the direction of light by taking theta 1 and adding theta 2 prime and subtracting the apical angle of the prism. It's a little bit different when we talk about an ophthalmic prism. An ophthalmic prism would be one that we would prescribe in a pair of glasses. So it's a thin prism. The apical angle is less than 15 degrees for it to be considered an ophthalmic prism. And they're situated in the glasses, and we prescribe them so that the incident ray and or the emergent ray are very close to normal. And so therefore we end up with very small refracting angles. So our theta 1, theta 2 prime, and everything in between are small. And when these situations are true, then our formula for the deviation can be simplified. And now becomes n of the prism over n of the surroundings minus 1 times the apical angle. One thing I wanted to point out here is if you look at the case of our thick prism, we could plot the deviation for each incident angle. And if you remember, we end up with a plot something like this, where you can then see the minimum deviation for that prism. But when we plot for a thin prism, the plot looks something more like this. And so as the incident angle changes, the deviation remains pretty much constant. And you can see that in your equation. It doesn't depend on theta 1 or theta 2 prime. Those aren't part of the equation. So as long as we know the index of the prism and its surroundings and the apical angle, we can determine the deviation. And that's, again, assuming that we're talking about small angles here. So usually angles less than 20 degrees. And as long as we're using those small angles, our finding for the deviation will end up somewhere here in the middle of this graph, and so it would be a pretty much constant deviation for those angles. So for example, if we want to know the deviation of an ophthalmic prism that has index 149 and an apical angle of 12 degrees, well, when you first think deviation, you might say, oh, it's equal to theta 1 plus theta 2 prime minus gamma. So we're missing information. We need to know the incident angle, at least, so that we can calculate, figure out the emergent angle and calculate the deviation. But because it's an ophthalmic prism, we can assume that the incident or emergent angles are near normal and that there are small refracting angles. So we don't need to know the information, and instead we can use the thin prism or ophthalmic prism approximation. So that's where we have, just based on the index of refraction of the prism and the surroundings, minus 1 times the apical angle. And so for this problem, it would be 1.49 divided by 1 will give you 1.49, and then subtract 1 and multiply it all by the apical angle, which we are given is 12 degrees. And for this, you would find that the deviation of this ophthalmic prism is 5.88 degrees.